Welcome to this video on thermodynamics. We will cover fundamental concepts including energy transformations, enthalpy calculations, spontaneity, and Gibbs equilibrium dynamics based on the NCERT curriculum. In thermodynamics, we define the system as the part of the universe under observation, separated from the surroundings by a boundary wall. The universe is the sum of the system and its surroundings. Systems can be open, closed, or isolated, depending on whether they exchange matter and/or energy with the surroundings. Internal energy U is the total energy stored in a system, and it is a state function, meaning it's path independent. The first law of thermodynamics states that the energy of an isolated system is constant, summarized by the equation delta U equals Q plus W. We also need to understand the sign conventions for heat and work. Mechanical work is done when a gas expands or contracts against external pressure. Irreversible processes involve a single step, while reversible processes occur through multiple equilibrium steps. The reversible work done for an ideal gas expansion is given by the equation shown. For a vacuum expansion, work is zero. Enthalpy H is defined as the sum of internal energy and the pressure-volume product. It is particularly useful for reactions at constant pressure, where the heat change, Q sub P, equals delta H. For reactions involving gases, the relationship between delta H and delta U is linked using the ideal gas law, considering the change in the number of moles of gas. Thermodynamic properties are classified as extensive or intensive. Extensive properties, like mass and volume, depend on the quantity of matter. Intensive properties, such as temperature and density, are independent of the amount of matter. Heat capacity, C, relates heat transfer to temperature rise. The molar heat capacities at constant pressure, Cp, and constant volume, Cv, for an ideal gas are related by the equation Cp minus Cv equals R. Calorimetry is the experimental method used to measure energy changes. A bomb calorimeter measures heat at constant volume, leading to delta U as work is zero. A constant pressure calorimeter measures heat at constant atmospheric pressure, resulting in delta H. Hess's law of heat summation follows from the path independence of enthalpy, a state function. It states that the overall enthalpy change of a reaction is the sum of the enthalpy changes of its intermediate steps. This law allows us to calculate enthalpies for reactions that cannot be measured directly. Lattice enthalpy is the energy needed to dissociate 1 mole of a solid ionic crystal into its gaseous ions. Since this cannot be measured directly, we use the Born-Haber cycle, a series of individual thermodynamic steps combined via Hess's law to calculate it indirectly. This cycle includes sublimation, ionization, dissociation, electron gain, and formation steps. The first law doesn't predict spontaneity, which is where entropy comes in. Entropy S measures the disorder in a system. The second law of thermodynamics states that for any spontaneous process in an isolated system, the total entropy of the system and its surroundings must increase. Gibbs free energy G combines enthalpy and entropy to determine spontaneity, avoiding the need to calculate surroundings entropy. A negative delta G indicates a spontaneous reaction. Delta G is also related to the equilibrium constant K via the equation shown. Here is a quick recap of the core thermodynamic concepts and important exam tips. Pay close attention to the sign conventions for heat and work. Practice relating delta H and delta U for gaseous reactions and calculating equilibrium constants using Gibbs energy. This slide lists the image sources and attributions used throughout this video, including diagrams for thermodynamic systems, calorimetry, the Born-Haber cycle, and phase transformations. This final slide lists the source URLs for all images used in the video. If you have any further questions, please refer to your standard NCERT back exercises or consult your class instructor.